Good morning. Now we'll see about strain gauge and their types. So what is meant by strain? So strain is the amount of deformation of a body due to an applied force. More specifically, strain is defined as the fractional change in length. So whenever a force is applied to an object, the deformation or compression takes place in that object. That such kind of changes in that material or object to be called as strain. So when a stress is applied, the strain has the output is strain. So whenever the stress is applied to such kind of a object or thing, there is a strain. There is a result. The result of that stress to be called as strain. A positive strain is the result of stretching of a material, and negative strain is the result of comparison. So this is the main diagram for a strain gauge. So this is the leads in which here only the inputs that to be a stress is applied, a force is applied in the leads, in which there is a deformation or compression takes place in the metallic grid pattern. Then this is the test specimen. So whenever there is a stress applied in the leads or force applied in the leads, there is a change in either it is elongated or it is compressed, or to be specified as positive strain or negative strain that applied in the metallic grid. So that to be called as strain. Then a fundamental parameter, here a fundamental parameter of strain gauge is its sensitivity to strain expressed as gauge factor. So what is meant by gauge factor? It is defined as the ratio of fractional change in electrical resistance to the fractional change in length. So here there is a formula. Here this is the formula to find the gauge factor. So del R is the change in resistance divided by resistance, original resistance, to the ratio of change in length with the original length. So we can go for this del L by L as epsilon. So epsilon, which is nothing but strain. So gauge factor equal to del R by R divided by epsilon, so which is proportional to the strain. So this is the change in resistance, this is the original resistance. So R is the resistance, del R is the change in resistance, L is the original length of the material, and del L is the change in length. So we can measure the gauge factor of such kind of materials which produce any strain. Then move on to the types of strain gauge. So based on the principle of working, we can classify the strain gauge as mechanical, electrical and piezoelectric. So based on mounting, based on its mounting, we can classify the strain gauge into two types: bounded strain gauge and bounded strain gauge. Then based on construction, we can classify this strain gauge as wire wound strain gauge, foil type strain gauge and semiconductor strain gauge. So we can now we'll see about wire wound strain gauge. So wire wound strain gauge, we have two types: bounded strain gauge and unbounded strain gauge. So now let's see about unbounded strain gauge. So unbounded strain gauge consists of two wires stretched between 2 points. So this is the two wire stretched between 2 points. So consist of wire stretched between 2 points in an insulating medium. So this is the insulating medium. The diameter of the wire used is about 25 micrometer. So this wire's micrometer is 25 micrometer. Diameter is 25 micrometer. When an external load is applied, so whenever an external load is applied in the diaphragm, the resistance of the strain gauge factor derivation changes, causing an unbalance of the bridge circuit, resulting in an output voltage. So here the wire wounding might cause some unbalancing changes, in the output. The voltage is proportional to the strain. A displacement of the order of 50 micrometer can be detected with these strain gauges. So up to 50 micrometer order we can measure from this unbounded strain gauge. So this is the construction of unbounded strain gauge. Whenever an external force is applied on the diaphragm, the wire wounding of 1 and 2 strain gauges, wire wounding can be changes in the wire wounding 1 and 2, and we can measure the output voltage in terms of strain. So every a displacement might have order up to 50 micrometers. So how much the amount of diameter of a wire, in a sense 25 micrometer. So this is the unbounded wire wounded strain gauge. So next, this is the another type of unbounded strain gauge. It has two frames. So this is the frame. This is the frame Q and this is the frame P and this is the frame Q. So to measure strain, the gauge is connected to Wheatstone bridge. Whenever a force is applied on the frame, the length and area of gauge will changes due to the strain. So whenever the pressure or force applied on the frame P, it impacts on the frame Q. So there is a change in the length or a change in the position of the wires. So the strain changes the resistance of the strain gauge, and this changes in the resistance is measured using Wheatstone bridge. So how can we measure these strains? So we can measure these strains using Wheatstone bridge. So this is the another format of unbonded strain gauge. I'll see about bonded strain gauge. So strain gauge is composed of a metal foil insulated by a flexible substrate. The two leads pass a current through the gauge, and a surface of object of being measured stressed, stretches or contracts. The change in resistance is measured. The change in resistance is proportional to the change in length of the surface. So this is the bonded strain gauge. So here is the resistance measured between 2 points. So whenever the force is applied to the leads, the metallic grid patterns might be changes. Either the tension causes resistance increases or compression causes resistance decreases. So here it will be move either right side or left side. So it will be positive strain or negative strain. Either it is compressed or it will be tension causes, that is elongated. So this to be called as bounded in the sense it mounted on a fixed surface. So that to be called as bounded strain gauge. Then move on to strain gauge characteristics. The strain gauge should have high value of gauge factor. So every strain gauge might have high value of gauge factor. The resistance of strain gauge should be high as possible, since this minimizes the effect of undesirable variation of resistance in the measurement circuit. The strain gauge should have low resistance temperature coefficient. To maintain consistency of calibration, the strain gauge should have linear characteristics. The strain gauge are frequently used for dynamic measurements, and hence their frequency response should be good. Then move on to foil strain gauge. So this is the types of foil strain gauge. So this is the wire type strain gauge. This is the foil type strain gauge. So whatever the wire might be arranged in such kind of patterns. So here the foil arranged in such kind of patterns. So this makes the difference of wire and foil type. So it is an extension of resistance wire strain gauge. The strain is sensed with the help of metal foil as against metal wires. Gauges have a much greater dissipation capacity as compared to the wired type. So advantages in the sense of foil can be fabricated economically. So economically we can fabricate this foil type strain gauge. Then comes to semiconductor strain gauge. So the semiconductors wafer or filament having length of 2 millimeter to 10 millimeter and its thickness is 0.05 millimeter are bounded on a suitable insulating substrates. For example, Teflon. The gold leads are usually employed for making electrical contacts. The assembly is placed in a protective box. Semiconductor materials such as germanium and silicons might be used. When strain is applied to the semiconductor element, a large change in resistance occurs, which can be measured with the help of Wheatstone bridge. The strain can be measured with high degree of accuracy due to relative high changes in resistance. So this might be the semiconductor strain gauge. So semiconductor strain gauge, here a metal surface is there. Under that a semiconductor we can place a two wire terminals will be two other ends, that might be gold wire. So this is the two terminals. Whenever the pressure applied, semiconductor materials might have some changes, so we can we can measure those changes by using Wheatstone bridge. So what are the advantages of semiconductor? So it have high gauge factor. Already we see the characteristics of strain gauge. First characteristics is strain gauge might have a high gauge factor. Then it can be used to measure small strains. then it have long life and high durability. What are the disadvantages? Means sensitive to change in temperature, difficult to attach with a structure, and it might be some cost expensive. So these are the advantages and disadvantages of the semiconductor strain gauge. Thank you.